All right, let's dive into something that's a huge part of our digital lives, whether we realize it or not: recommender systems.
You know that feeling, right? When your favorite streaming service or online store suggests something and you're just like, whoa, how did they know? It seriously feels like they're reading your mind, but it's not magic. It's actually a really cool data science problem, and we're going to pull back the curtain to see exactly how it all works.
Okay, so where do we even begin? Well, it all starts with taking all of our actions, every single click, every rating, and translating them into a language that a computer can actually work with. We're turning our tastes into a data problem.
So at its absolute core, a recommender system is just a prediction engine. That's its whole job. It looks at you, it looks at something you've never seen before, and it makes its best guess. Its most educated guess on how much you're going to like it.
Now, if you've ever worked with relational databases, this will sound super familiar. Just think about it. You've got two main things, right? Users and items. A rating, that's just the connection, the relationship that links a specific user to a specific item. And usually it has a value attached, like that 5-star review you left.
Let's make this real. Look at this little table here. It's a tiny snapshot of some users and what they thought of a few movies. You got John, who's clearly into sci-fi and fantasy. Anne's got diverse tastes, Star Wars and Pride and Prejudice. Richard seems to be a romance fan. And then there's Pat. We see a couple of Pat's ratings, but see that question mark? That's our whole goal right there. We need to predict what Pat would think of Pride and Prejudice.
And right there, that is the biggest challenge of all. I mean, think about it. In the real world, how many of the thousands of movies available have you actually rated? A tiny, tiny fraction, right? So if you pictured this as a giant spreadsheet with every user and every single item, almost all of it would just be blank. And that's what we call a sparse matrix.
So, that's the puzzle, isn't it? With all that missing data, how on earth can we make a good guess for Pat? Well, it turns out there are a couple of classic ways people have tried to tackle this.
You can pretty much boil it down to two big ideas, two main schools of thought. The first one is all about finding people who are like you. The other one is more about digging for hidden patterns inside the items themselves.
And these two approaches really are fundamentally different. The neighborhood approach is super intuitive. It's basically digital word of mouth. Find people who like the same stuff you do and see what else they liked. Simple. The latent variable approach, though, is a bit more abstract. It's trying to be a detective, uncovering these hidden qualities, things that aren't in the description, like maybe dark humor or 80s nostalgia, and then it matches you to movies based on those hidden vibes.
Okay, so one way is simple and the other is really powerful. The natural question is, what if we could get the best of both worlds? What if we could combine them and maybe, just maybe, add a secret ingredient that almost everyone else was overlooking?
And that's exactly what brings us to the main event today, a really clever hybrid algorithm called SVDPlusPlus. And let me tell you, when this came along, it was a total game changer for making recommendations way more accurate.
So SVDPlusPlus has this kind of 3-layer recipe for success. It starts with that pattern-finding approach we talked about, the latent variables. Then it makes some smart adjustments for basic human and item biases. But the real magic, the thing that sets it apart, is that third piece. It uses something called implicit information.
Let's break that down. The first layer is really just common sense, building a baseline. You start with the average rating for everything, just the global average. Then you start tweaking it. So for Pat, is she a tough critic? Does she give out low scores in general? Okay, we'll nudge the prediction down a bit. And what about the movie Pride and Prejudice? Is it a classic that almost everyone loves? Okay, we'll nudge the prediction up. It's that simple. We're just accounting for user and item biases.
All right, now for level 2. This is where that cool pattern matching stuff comes in. The algorithm digs into Pat's rating history and builds a kind of profile of her hidden tastes. At the same time, it does the exact same thing for the movie to figure out its hidden profile. The final step? See how well those two profiles click. The better the match, the more it adjusts the prediction.
And here it is. This is the secret sauce. SVDPlusPlus was so smart because it realized that the very act of you rating something tells a story, totally separate from the score you give it. Think about it. If you take the time to rate 100 sci-fi movies, even if you gave half of them 1 star, you've screamed to the system, hey, I'm interested in sci-fi. That is the implicit feedback. It's not what you said, it's what you did.
So how do you get all this working together perfectly?
Well, data scientists have these things called hyperparameters. The best way to think of them is like tuning knobs on a fancy stereo. You can twist one to decide how many hidden genres to look for. You can turn another to control how fast the model learns. It's all about fiddling with these knobs to find that sweet spot, that perfect balance, to get the most accurate prediction you possibly can.
Okay, so after all of that, the biases, the patterns, the implicit feedback, what happens when we unleash this thing on our original question?
So, the model has been trained. It's looked at the biases, it's matched up the hidden features, and it's factored in that all-important, implicit data. It's finally time to answer the question we asked right at the beginning.
And the answer is 3.95. After all that work, the model predicts Pat would give Pride and Prejudice a 3.95 out of 5.
So why does any of this matter? Well, because by blending all these things together, the simple biases, the complex hidden patterns, and our own implicit behaviors, SVD++ paints a way more detailed, a much more nuanced picture of what we actually like. This kind of hybrid thinking is exactly why the recommendations we see every day feel so magical. It's the engine behind the best systems out there.
And that kind of leaves us with a final question to chew on. The next time you're just browsing online, or you watch a trailer, or even just skip a song, take a second and think about the data you're leaving behind. What are those little implicit signals telling the system about you? And how is it all being used to predict the next thing you're going to fall in love with?
And that's it for this breakdown. Hey, if this helped you finally understand a little bit of the magic behind recommendations, do me a favor and hit that like button. Share it with someone you think would find it cool, and definitely subscribe for more deep dives into the tech that's all around us. Thanks for hanging out with me.